Hello friends, in this video we will study about middleware's distributed transparency and its type, model of distributed systems and some difference between and we will look after the exam's questions. Let's discuss about middleware. As distributed operating systems has lack of scalability and network operating system fails to provide single coherent view, so a new layer is formed between distributed operating systems and network operating systems which is called middleware. As we can see in the diagram, here are two machines A, B and C which have their own kernel and network operating systems connected on the network, and middleware services are kept in between the network operating systems and the distributed applications. This is the diagram of middleware. Now let's discuss. A common set of service is provided for the local applications and independent set of services for the remote application. It supports heterogeneity, that is, it supports multi-language and operating systems where user get freedom to write the application using any of the supported language under any platforms. Middleware provides the following services such as locating the object by their names, finding the location of the objects, maintaining the quality of services, handling the protocol information, synchronization between the systems, concurrency and security of the objects. And this is the diagram. Distributed transparency. We have already discussed about distributed transparency in the previous video. Now let's discuss about this. The transparency in distributed systems is defined as the hiding the fact that the process and resources are physically distributed across multiple computers from the user and the application programmer. The aim is to make certain aspects of distribution invisible to the application programmer so that they can concern with the design of the particular applications. There are different types of distributed transparency. There are access transparency, location transparency, relocation transparency, migration transparency, replication transparency, concurrency transparency, and failure transparency. There are 7 types of transparency. Access transparency. It hides the representations that how they are accessed between the systems. Location transparency. It hides where our resources is located in the systems. Relocation transparency. It hides that a resource may be moved to another location while in use. While the resources are used in the systems, they can be moved to the another resources. So that is hid by the relocation transparency. Migration transparency means move to another locations or migrated to the newer versions. It hides that a resource may be moved to another location or is migrated to the newer version. Replication transparency. Replication means copied. Hide that a resource may be copied in several places. Concurrency transparency. It hides that a resource may be shared by multiple users at the same time. Failure transparency. Hides the failure and recovery of the resources. Now let's discuss about model of transparency. In distributed systems, there are 2 types of models. They are architecture model and fundamental model. Architecture models deals with the organization of the component across the networks of computer and the interrelationship. They are divided into further 2 types. They are client server model and the peer-to-peer model. Client server model. Client server model is the most and widely used distributed architecture model. Whenever the client is requesting, server has to provide the services. Whenever the client is requesting, the server has to provide the services. So the time when the server is providing the services, client has to wait for the result until the server reply. When the server is providing the result, client have to wait. This is the waiting for the result, and when server provides, it gets the reply. This is the timing diagram of client server model. Client process interact with individual server processes in a separate host computer in order to access the shared resources. This is the diagram of client server model. Here client is invocation to server, that is client is requesting to the server and server is giving the result. Here multiple clients and multiple servers are present. In client server architecture, the systems can act as a server as well as client based on the requirement of the systems. Here multiple clients and multiple servers are present. This server is also okay as a client. Here this server is requesting to this server and the server is giving to the result. Sometimes server will also act as a client. Peer-to-peer model. Unlike client-server model, peer-to-peer model does not distinguish between client or server. Instead, each node can either be a client or server depending on whether the node is requesting or providing the services. Here, each node is considered as a peer. Here are 5 peers: peer 1, peer 2, peer 3, peer 4, and peer 5 to peer n. These all are applications. These are all shareable objects. Peer 1 is requesting to peer 3 and peer 3 is giving the result. Similarly here peer 1 is requesting and peer 5 is giving result. This is the diagram of peer-to-peer model. Pattern of communication between them depends entirely on the application requirement. The pattern of communication between them entirely depends on the application requirement on your systems. Each object is replicated in several counters to further distribute the workload and to provide the recovery from some difficulties, that is when the event of when some counters are disconnected. Here these are the shareable objects. These objects are replicated on different applications. When some of the nodes are faulty, then this shareable object can be shared by another peer. So they are replicated on different applications. It is more complex than client server as it needs to place and extract data from individual counters. Fundamental model. Fundamental models deals with the communication that can be affected by delay, failure, and security attack. There are 3 types: interaction model, failure model, and security model. Interaction model, dealing with the interaction of processes such as performance and event ordering, that is timing. Interaction processes are affected by 2 significant factors: performance of communication channel and computer's clock. In performance of communication channel, there can be latency, means a delay between the sending and receiving of the message. If T1 be the sender and T2 be the receiver, then the delay between T1 and T2 is the latency. Bandwidth, amount of information transmitted per unit time, is the bandwidth. Computer clock. Each system in distributed system has its own internal clock and can result in different time reads value when 2 processes running on different system at different places. Such as S1 is the systems that is placed in Nepal, S2 is the system placed in USA, and S3 is the system placed in India. S1 system of S1 can have different times. Similarly, T2 have different time and T3 have different time. We have to send one process. When we send the process between 3 different system placed in different places, they can receive the process at different times. Failure model. It is the important to understand the kinds of failure that may occur in the systems. Type of failure. There are 5 types of failures. They are omission failure, arbitrary failure, timing failure, fail stop, and crash. Omission failure. Omission failure refers to the cases when a process or communication channel fails to perform actions that is supposed to do. In process failure, some process may crash or some system may not respond to the other. Communication failure. In communication failure, the loss of message between sender and buffer, or buffer and receiver. There can be message lost between the sender and buffer and receiver. Arbitrary failure. Any type of error can occur in either process, channel, or both. Process failure. In process failure, not the process are not performing the correct step or doing unintended steps. Channel failure. The message may be corrupted or message may duplicate accuracy. Timing failure. Timing failure are applicable only in synchronous distributed systems where the time limits are set on process execution time, message delivery time, and clock drift rate. Fail stop. Whenever a fail stop occurs, a process halts and remain halted. Other process can detect that the process has failed. But in crash failure, a process halt and remain halted. Other process may not be able to detect this state. Security model. Security models helps in securing process and communication channel from unauthorized access. There are several potential threats a system designer need to be aware of. Threat to process, threat to communication channel, and denial of services. Threat to processes. An attacker sends unauthorized request or response using false identity. Threats to communication channel. An attackers can copy, alert, or inject message on the channel. Denial of service. An attacker may overload a server by making excessive requests. These things can be protected by using the authentications. Here are difference between distributed systems and distributed operating systems. Purpose of distributed systems is for achieving a common goal, and purpose for distributed operating system is for providing common set of services and the resources. Node software. Each node runs its own software. Each node runs the same operating systems. Resource sharing. Sharing of resources such as memory, storage, and processing power. Sharing of resources such as file systems, process management, and inter-process communication. Abstraction. No operating system layer provides a layer of abstraction over the underlying hardware and network infrastructure. Coordination. Nodes coordinate with each other to achieve the common goal. Node works together to provide a common set of services and resources in distributed operating system. Example of distributed systems are internet, cloud computing, peer-to-peer, file sharing networks. Example of distributed operating system is Omeba, Locust, etc. Difference between centralized systems and distributed systems. The architecture of centralized systems it has a single point of control. The distributed system has multiple point of control. Resource management. All resources managed by a single operating system. Each node manages its own resources. Difficult to scale up, easily scalable by adding more nodes. Communication occurs between center server and client. Communication occurs between nodes and nodes may communicate directly with each other. Fault tolerance. Centralized systems cannot continue to operate due to single point of failure. Distributed systems can continue to operate even if one or more nodes fail. Example of centralized systems are mainframe computers, supercomputer, database systems, and so on. Example of distributed systems are internet, cloud computing, peer-to-peer file sharing networks, and so on. Now let's discuss on the past question. Here are some questions that are asked in the exams. What is distributed systems? What are the design challenges of distributed systems? Application of distributed systems. Explain the advantage of distributed systems over independent pieces. Explain different issues while designing distributed systems that we have already discussed. Failure model in short notes. What is transparency in distributed systems? Describe different form of transparency. Explain why and how middleware plays vital role in distributed systems. How distributed system is differ from distributed operating system. Explain different system models. What are the major role of middleware systems? Model of distributed systems in short note. Explain the major characteristic features of distributed systems. Explain interaction model of distributed systems and give example for your own distributed systems. Differentiate between centralized and distributed systems and list out the main characteristic of distributed systems. In the examples of distributed systems, you can give the event ordering that we will discuss in the unit 3. In next video we will study unit 3,